Okay, Cappuccino, here we go with problem number 7 from Mathspace related rates. Again, your picture might have slightly different numbers, but it's the same basic idea. We have a tree that's 3 meters tall. So I'm going to be taking notes while I do this, while I talk, and then I am going to switch over to the dock camera to show you how I do it. Okay, so I am copying down the picture. My tree is going to be 3 meters tall, so I'm putting a 3 on there. It shows me where X is and where Y is and where angle A is. And then it tells me the angular velocity of the angle of elevation as the sun moves across the sky is pi over 8 radians per hour. Okay, so that's an angle and time. So that would be, that pi over 8 is my dA dt. dA dt is pi over 8. The rate that the angle is changing in regards to time is equal to pi over 8. So I already have one of my derivatives already. dA dt is equal to pi over 8. Let the length of the shadow be x meters and the length of the hypotenuse be y meters. All right, so I got my information. Okay, next, find the rate of change of x when a is equal to pi over 4. So remember, your problem might have a different number. The first time I did this problem, it gave me pi over 6. So you might have a pi over 3. But notice pi over 4 is something that's on our unit circle. So we are going to use our unit circle for this problem. Okay, so find the rate of change of x when a is equal to pi over 4. So that means I need to find dx dt. I'm trying to find dx dt, and I know that a is equal to pi over 4. Okay, so now I have all my information. So now I'm going to go ahead and switch over to my dock camera. So let's see. I can set this up, okay? And hide my bar. All right, so here we go. So here's my picture, and I know that dA dt is pi over 8. This is what I'm trying to find. I'm trying to find dx dt, and I know that a is equal to pi over 4. Okay, so I don't have an expression with x yet. I have an expression with a and with t. I know I need to keep that t, so I'm definitely going to be using these, but I need to write an expression for x. So I don't want to write an expression for both x and y if I can avoid it. I'd rather just have one variable in it, or actually, I'm going to have 2 variables, but I don't want to introduce the y yet, because right now I see I have an a t, an x, and a t. So I want to write something in terms of x and a. Okay, I want to write something in terms of x and a. So I'm going to put these 2 together. How can I do that? Well, I can use my trig functions. So the a is the adjacent, and I know the opposite, so I can use tangent. The tangent of a is equal to opposite over adjacent. Now I want to solve this for x, because if I can do dx dA and multiply that by dA dt, then I will be left with, the dA's will cross out, and I'll be left with dx dt. Okay, so I want to write an expression for x and a so that I can take the derivative of it. And that way, when I multiply it with dA dt, I'll be left with dx dt, which is what I'm trying to find. Okay, so this, though, isn't solved for either a or x. So right now, it's not too much use to me. But I want to solve it for x, because see, x is on the top. So I'm going to multiply both sides of the equation by x. So the x is going to come up here. And then I'm going to divide both sides of the equation by tan a. So I'm going to end up with x equals 3 over tan a. So I hope that's okay, that you don't mind that I went ahead and switched those rather than showing every single step. Okay, now I can take the derivative of this. When I take the derivative of this, it's going to be dx dA. Okay, I'm taking the derivative of x in respect to a. So now this is kind of a doozy to take the derivative of this. I don't like having fractions. I'm going to rewrite it as 3 times tangent to the -1. And now I'm going to use my chain rule. I'm going to do -1 times 3 is equal to -3 tangent of a to the -2, because I got to subtract 1 from that. Now I need to write times the derivative of tangent. The derivative of tangent, it's in your formula packet if you don't remember, but it is 1 over cosine squared. So 1 over cosine squared, A. Okay, so that's my dx dA. That kind of looks like a mess. I don't think I want to go and put it into here yet. Let's see if I can simplify this a little bit. This might remind you a little bit of the warm-up that we did. We had a thing where we had tangent and cosine, and we were able to simplify it. So let's go ahead and see if we can do that. So I have the -3 is going to stay on top. So I'm going to have -3. And the tangent is going to come to the bottom. So I'm going to have tangent squared of A, because when I move it to the bottom, it becomes positive, times 1 over cosine squared of A. And now you might remember from our warm-up that tangent can be written as sine over cosine. So if I change this, see, whenever I have tangent and cosine, or tangent and sine, I can actually do some reducing. So 3 over, -3, don't lose those negatives. Tangent I can rewrite as sine over cosine, so sine squared over cosine squared times, oops, I should have put the times up there, right? Times 1 over cosine squared. And then look what happens. Oh, I can get rid of the cosine squareds, okay? Because I'm just multiplying my denominators together. So that's going to just equal 1, so that goes away. And I'm left with -3 times 1 is -3 over sine squared alpha. All right, so that big mess just simplified to this. And that is my dx dA. Okay, there's my dx dA. So now that is right, if we go back up to here, my dx dA is going to be -3 over sine squared A. And I'm going to multiply that by my dA dt, which I was given as pi over 8. So that's going to be my dx dt. So sorry, I'm running out of paper here, so I'm going to squeeze it in. Okay, so if I multiply this, I get -3 pi over 8 times sine squared of A. And I know what A is. I'm going to evaluate this for the value A is pi over 4. So I'm going to go ahead and put that in, pi over 4. And that's my dx dt. Okay, and we could enter that into Mathspace right now to make sure we're doing okay, but I'm just going to go ahead and keep going. So I want to find the sine of pi over 4. So on my unit circle, if I do pi over 4, that's 45-degree angle. So that's √2 over 2, comma √2 over 2 are the coordinates there. So the sine is √2 over 2. So here, let's rewrite this. I have -3 pi over 8. And now sine squared of pi over 4, well, sine of pi over 4 is √2 over 2. And that's going to get squared. Okay, that's my dx dt. My goodness. Okay, so I need to square my √2 over 2. √2 squared is just 2. So I have 8 times 2, and then 2 squared is 4. Okay, 2/4 is the same as 1/2. 1/2 of 8 is 4. So I'm going to have -3 pi over 4. And let's hope that's it, because I'm doing this problem for the first time. So let's see. Why won't it let me? Nope. Shoot. Why can't I shrink this back down? Oh no, I'm stuck. Okay, there we go. I'll stop my sharing. There we go. Got back to Mathspace. All right, let's just see if it'll do it. Find the rate of change of x when A is pi over 2. So I'm doing dx dt is equal to, and I said I got -3 pi over 4. -3 pi over 4. Crossing my fingers. Bam! Yay! Okay, got it. All right, so now I'm going to do the same thing again, but now I'm going to do it in regards to y. So I'm going to do basically the exact same thing, except instead of x, I'm going to look at it from the point of view of y. Right, so let me just move back to my paper. So they don't give me any new information. It's all the same information as before. It's just now I'm going to be using y instead of x. So go back to my document camera. Okay, so now I'm going to be using y instead of x. So instead of using tangent, I can use sine, opposite over adjacent. So I'm going to use sine of a is equal to 3 over y. So I can solve for y is equal to 3 over sine of a. So then I can do dy dA, and I can take the derivative of that. But before I do that, let's just see where am I heading. Because remember, I set this up before I started doing all the hard work. So I can find dy dA, and I know dA dt is pi over 8. So once I have dy dt, I can just multiply that by dA dt, and I'll get dy dt. Oh, piece of cake. Okay, so it's not that bad. So I just need to take the derivative of this. Okay, so let me put this on another piece of paper. So I know, sorry, that's not what I wanted to write. Y equals 3 over sine A, and I'm going to find dy dA, and I already know dA dt is equal to pi over 8. So I will be able to do dy dA times dA dt. The dA's will cross out, and that'll leave me with dy dt. Okay, so I'm good. All I got to do now is find the derivative of this. Okay, so let's first rewrite it. Actually, before I find its derivative, let's go ahead and rewrite it. I don't need that piece of paper anymore. So I'm going to rewrite this y equals 3 times sine a to the negative 1. And then I'm going to have y is equal to negative 3 times sine a to the negative 2. Using my chain rule, I need to multiply by the derivative of the sine of a, which is cosine of a. Okay, and that was, oops, sorry, that's my dy dA. Don't want to forget that. Okay, so this is my derivative. And then I could simplify this. I could write it as a fraction. So dy dA is equal to negative 3 cosine A over sine A squared. Put the square right there. Oops, sorry, you can't see that. All right, and now I'm going to multiply that. That's my dy dA. I'm going to multiply that by dA dt to get dy dt. So dy dt is going to be equal to dy dA times pi over 8. And just like before, my a for this problem, my a is pi over 4. And remember, your a might be something different. All your numbers might be a little bit different, but I'm still going to use my unit circle. Whatever they give you for a is on the unit circle. Okay, you want to use exact values. All right, so I'm going to go ahead and simplify this and substitute in my pi over 4. So I'm going to put negative 3 pi times cosine of pi over 4 over sine squared of pi over 4. So pi over 4, both the cosine and the sine of pi over 4, oh, they happen to be the same thing. So this actually is going to reduce out pretty nicely. Because remember from our unit circle, the coordinates here at pi over 4, it's root 2 over 2 for both the x and the y coordinates. So both cosine and sine are root 2 over 2. So I'm going to have negative 3 pi times root 2 over 2. And then in the denominator, it's going to be root 2 over 2 squared. Okay, and now I can simplify this. I am going to do this. I have root 2 over 2 over root 2 over 2 squared. So I'm going to be able to reduce out one of these. This one and one of these is going to reduce out. So I have negative 3 pi divided by root 2 over 2. That's my dy dt. And I'm dividing by a fraction, so I can multiply by the reciprocal. Times the reciprocal would be 2 over root 2. And so I end up with negative 6 pi over the square root of 2. Okay, let's cross our fingers and hope that that is right. All right, I learned my lesson here before. I got to stop sharing to get out of here. Here it is. All right, so it's going to be dy dt is equal to negative 6 pi over, oh, I need a square root. Square root. Oops. Come on. Square root of 2. All right, fingers crossed. No, what did I do wrong? Oh, shoot. And so this is where I take a break and I see what I did wrong before I continue with the video. Okay, I'm going to take a break. I should have practiced before I started making the video. Oops, my bad.